So we are back from our momentary delay, and we will continue where we left off. So just as a quick reminder, the last thing that we stated was that we needed two requirements in order to decide and understand when Tzedek Kochavim occurs after Shkia. And we said the first one was location. And as we pointed out in the globe over here, person A, standing at the equator, would see the sunrise and sunset occurring in a circular fashion. And the more north you go, person B or person C, we see that it becomes, relative to them, more and more curved, more and more horizontal. And because it becomes more horizontal and more curved, and we said that a curved line will have a greater distance than a straighter line, therefore it's going to take longer and longer the more north you go, or the further south you go, correspondingly. So now we have the second requirement as well, which is, we'll make that a Nathan, which is time of the year that occurs. Let me get the eraser, please. That's fine, I'll do it. Besides the common globe that we use today, the one that shows all the continents and the oceans, there's a more sophisticated type of globe, and it depicts something called the celestial sphere. It's called the celestial globe. What is it exactly?
What is it, Sam? Do you know anything about it?
It was dealing with the whole galaxies above. I mean, not galaxies, I'm sorry, the stars above.
Take, for instance, a person that's standing on the surface of the earth. I'm going to give him a nice keep over here. Right? Standing on the surface of the earth. And we know above the earth we have countless amount of constellations, stars surrounding him. All around him. All around the earth. So if we say that the earth is the center of the world, if we were to say that, therefore everything else is surrounding it, and we can make a globe out of it showing that the positions of all the stars relative to the earth in a sphere. What we call this is a celestial sphere. Celestial in Latin comes from the word celestia. Salem means heaven, the sky.
Who was the celestial kingdom?
Now we're going to give like different coordinates and different measurements for the sphere, and it's going to be maybe a little too much over here going on, but slowly we'll be able to understand what's happening. This dot over here is going to represent the center of it. We're going to say this is planet Earth, and everything else around it, including the sun, is going to be surrounding it. All right, all the constellations, anything you could imagine in the solar system is going to be surrounding the Earth. If that's the case, just as in any other sphere, we have a center, which is called the equator. Commonly, we would call it the celestial equator. Okay? We'll just abbreviate it to the C equator. We also have what is known as a celestial North Pole. North Pole. And similarly, a South Pole underneath it. Okay? Celestial North Pole, celestial South Pole, and the celestial equator. Now somewhere along this line, in this sphere over here, we're going to have the sun surrounding this dot of Earth, what we call planet Earth. Now, if we could recall, we said that relative to the sun, the Earth is tilted on a 23-degree axis. That's according to the approach that says that it's really the sun that is the center and it's the earth that goes around it. But if we say that it's really the earth that's the center and the sun goes around it, it's not that the earth is tilted, but rather the sun goes in a tilted fashion. And it would also be by the same amount of degrees. Therefore, the sun goes around the earth in a 23.5 degree axis as well. This is the path that the sun would take around the earth throughout the entire year. We call this path, what do we call it?
Celestial path.
The ecliptic. The ecliptic. And just as we have a celestial South Pole and a celestial North Pole, similarly we have an ecliptic North Pole and ecliptic South Pole at the points in which they merge. So this would be the ecliptic North Pole. This would be the ecliptic South Pole. And over here we have the distance between the ecliptic and the equator, the celestial equator, 23.5 degrees. All right? Now we're going to have to see exactly how this works. Chart over here as well. Now, according to those who follow the geocentric approach, they hold the following: that any point in which the ecliptic, this curved path over here, touches the equator, this becomes what was known as an equinox, meaning either the spring or the fall season. The vertices at either end, the furthest becoming the summer, or at the bottom it becomes the winter. The winter solstice and the summer solstice. As we approach north and we touch the equator over here, it becomes spring. Into summer, goes back down, touches the point over here, becomes fall. All right? Now, what's interesting about the sun in this scenario is that it has two distinct motions. It has what we call a daily cycle, and it has a yearly cycle, which go completely different directions. How so? If over here is summer, right, the longest day of the year, we said what direction does the sun rise and what direction does the sun set? It goes from east to west every day, right? It rises in the sun, the sun rises in the east, and it sets in the west in direction, right? So if we're going to point it out, every day the sun will go from east to west, east to west, east to west, to set, only to come back the next day over here and do the same path. East to west, and it goes around this pattern the entire year, going more and more down, more and more up, through the ecliptic. East to west every day. Like we see it normally. The way we see it every single day. We find the horizon. Sunrise occurs over here, and sunset occurs in the west. And that's one path it takes every single day. Counterclockwise. Counterclockwise. But the sun takes a different path as well. The sun, because it needs to travel through the whole ecliptic, touch the celestial sphere, all around, one complete revolution every single year, it goes not from east to west. But what's the first month of the year? January, right? So if we're starting from January, we say it starts at this point, and instead of going from east to west, it goes from west to east throughout the year. Therefore, the yearly cycle is from west to east. So it makes huge revolutions every day from east to west, every single day from sunrise to sunset. But slowly and surely, after 365.25 days, it's going to make slowly but surely one revolution from west to east, clockwise. So that's as difficult as it gets. That's as difficult as it gets. The rest is going to be with concepts that we already dealt with. So we already dealt with location, but what does this have to do with the time of the year? We recall, one of the first things that we said in the lecture was, which part of a circle of a sphere travels the fastest? The middle. Why? Because larger distance to cover. Since it has the largest distance to cover, and it makes one complete turn the same time as every part of the sphere else, it has to travel faster in order to make up for it. Make up for the distance. So now let's look. Where's this thing? Thank you. Let's look. We say that the middle is the celestial equator, right? And we also said that during the spring and the fall respectively, is when the ecliptic touches the celestial equator. Since that's the case, right? If that's the case, and we say that at this point, since it's at the center, that it travels fastest, therefore the time between Shkia and Tzedek HaChavim will occur fastest during the spring and the fall months. But we said also, the further north or further south you go from the equator, it becomes smaller and smaller distance. And since it has less distance to cover, it will travel slower, which is the summer and the winter months, because they're further away, more south and more north. Since it's more south and more north, farther away from the equator, what ends up happening is that it will travel slower because it has to cover less distance. Okay? According to this, it's the same logic as we used earlier with the globe. When we said that the equator travels fastest. Why? Because it has more distance to cover. Same thing over here. During the spring and winter months, spring and fall months, it will travel faster because it has less distance to make up for. But more further up we go in the globe, it will travel less distance, therefore the time will be later. Same thing over here. Since we're go further up the globe or further below the globe, it has less distance to travel, therefore it will take longer. So according to the geocentric approach, we also see over here that the summer and the winter months will have a later Tzedek HaChavim, a later time lapse at Tzedek HaChavim than the spring and the fall months, due to that. Now, if we look at it, we can ask one question. And the question is like this. Since the summer and the winter are exactly the same distance from the equator, where the spring and the fall occur, we should therefore say that the time lapse between Shkia and Tzedek HaChavim will be the exact same during the summer and winter months. But we know that's not the case. We proved already that based on the heliocentric view, that the Earth goes around the sun, that the winter that the winter months has a shorter period than the summer months, with the summer being the longest. So therefore, based on this, it seems like it's a kind of a contradiction, because it's equidistant. But we're going to, for the finale, we're going to show why that's not the case. And it's going to be dealing with concepts we already dealt with. We know in the summer there's a greater amount of day than there is night, and in the winter there's more night than there is day. It's approximately 15 hours night and 9 hours day in the winter, and 15 hours day in the summer with 9-hour night. So if we were to draw the path of the sun, how it occurs throughout the summer and winter, if we were talking about the summer months, there'd be a greater portion of the sun above. Let's make this a little smaller to make it more visible. There'd be a greater portion of the sun being above the horizon than below the horizon, because their days are longer. But if we were to look at the winter, we would see the opposite. We would see that's a little different. Right? There's a greater night period than there is of day. Why is this important? Because Tzedek Kochavim, right, occurs after Shkia. So Shkia would be over here. Let's say the sun is over here. And we say Tzedek Kochavim occurs a little while after. Over here. Same thing would apply over here. During the winter months. Shkia, sunset applies, and it comes over here at this point. And Tzedek Kochavim occurs over there. Now if we look at it carefully, what we see is that the slant that it makes during the summer months is more slanted than the winter months. The time distance, right? We see that it's more at the center of the circle. Since it's more at the center, it becomes more vertical. Okay, but since at the summer months, when the sun's already dipping, it becomes more horizontal. You have a slope over here. It becomes more slanted. And again, we said whenever something's more slanted, it takes a longer period. Therefore, it's not a contradiction. Even according to the geocentric approach, we say that in the summer months, because of the slant, it's going to occur at a later time than winter. But nonetheless, during the fall and spring months, it will occur at the earliest time. That sums it up. I could take this out as well. We started saying in the very beginning that there were 6 opinions when Tzedek Kochavim occurs. And Rashi writes in Masechet Pesachim that this only occurs in Israel. The time that's being listed applies only in Israel, and only in the months of the spring and vernal equinox. Spring, the first day of spring, and the first day of fall. And based on all this, what we've been discussing throughout the period, we understand why. We said the farther north, the farther south you go, it becomes greater and greater. The time of year, the season that's at that current moment, also makes a difference. So Rashi's words is tremendously aligning, because he's showing that whatever we're saying, all these opinions, all the opinions of Rabbeinu Tam or the Gra and the Geonim, they only apply in Israel. But you cannot take the same number and apply it in America or in Europe or in Africa or wherever. It doesn't make a difference, because you're completely different locations. Since they're completely different location, everything has to be based on that period of time and that location in itself. So the last thing we have to do is, we saw in the first part of the series was what the Gemara spoke about, what the Geonim and the Gra and the Rabbeinu Tam spoke, how they understand the Gemara. And tonight we spoke about the Shanavic implications of these things and how it actually works. And of course there is a synthesis between the two of them, but that's only based on what the poskim are going to decide, taking all the information and bringing it together and showing the synthesis of the two of them, they're going to really show how we understand Tzedek Chavim and what is that which we follow today. And there are many agreements and disagreements between one to the other, as many other things, but there's a greater clarity. Again, Tzedek Chavim, and all these times, it might seem something very trivial. We might take it out of the phone and see on Maizman and what time it occurs. No, that is possible. But it's the understanding of how the depth of this, how it goes. It's amazing. There's a tremendous amount of knowledge that's required for it. And it's not something that's so pashut. It's not something that's so simple. But only by taking all the little bits of information that's been gathered for thousands of years, since the time of Chazal until modern day, are we able to really understand and appreciate exactly all the information and how the synthesis was applied. Thank you for joining us tonight, and have a good night.